Hello, dear children. In our previous presentation, we studied the theorem of areas of similar triangles. We will revise it once and then begin with practice set 1.4. What is this theorem of areas of similar triangles? Yes, we are given two triangles which are similar, triangle ABC and triangle PQR. Now, if triangle ABC is similar to triangle PQR, then we can say area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square, and that is equal to BC square upon QR square, and that's equal to AC square upon PR square. So the theorem says ratio of areas of similar triangles is proportional to the squares of the corresponding sides ratio. So using this, we will do practice set 1.4. Here, the ratio of corresponding sides of similar triangles is 3:5. Then find the ratio of their areas. So let's assume the triangles to be ABC and triangle PQR, and they are similar. Now, ratio of corresponding sides is 3:5. So I'll write AB is to PQ is equal to 3:5. So now we know when two triangles are similar, area of triangle ABC upon triangle PQR is equal to AB square upon PQ square, and the reason is, let's substitute the values. Yes, so now 3 square will be 9 and 5 square will be 25. So now what's the question? Find the ratio of their areas. So let's write the final step. Therefore, the ratio of areas of two triangles is 9:25. Let's move on to question 2. Yes. If triangle ABC is similar to triangle PQR and AB is to PQ is 2:3, then fill in the blanks. We just have to fill in the blanks. So area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Now, actually the reason is theorem of areas of similar triangles they have not asked, so we'll not write it. Is equal to 2 square upon 3 square is equal to 2 square is 4. 3 square is 9. So that's all we have to do in this question 2. Let's move on to question 3. If triangle ABC is similar to triangle PQR, area of triangle ABC is 80, area of triangle PQR is 125, then fill in the blanks. Area of triangle ABC upon area of triangle PQR is equal to 80 upon 125. Therefore, AB upon PQ is equal to that. Now we will have to do the calculation. We cannot write this values directly. So let's use this theorem of areas of similar triangles. So we are given triangle ABC is similar to triangle PQR. Therefore, we can write that the area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Reason is theorem of areas of similar. Now, here it is this is given to be 80 upon 125. Now 80 upon 125 can be reduced. Goes in the table of 5. So we will have it as 16 upon 25. Now that means AB square upon PQ square is equal to 16 upon 25. Both are equal to area of triangle ABC upon area of triangle PQR. So AB square upon PQ square is equal to 16 upon 25. Have a look at this step. AB square is a perfect square of AB. PQ square is a perfect square of PQ. 16 is a perfect square of 4. And 25 is a perfect square of 5. So all 4 terms are perfect squares. So we can take square root on both sides. Now it will become AB upon PQ is equal to 4 upon 5. This is what is asked. AB upon PQ is what is asked, and now we have got the value. So let's write down. Let's move on to number 4. Triangle LMN similar to triangle PQR. 9 multiplied by area of triangle PQR is equal to 16 multiplied by area of triangle LMN. If QR is 20, find MN. So let's take down this first. 9 multiplied by area of triangle PQR is equal to 16 multiplied by area of triangle LMN. The reason is given. Now we have to rearrange this so that we can use theorem of areas of similar triangles. Now since we are given triangle LMN similar to triangle PQR, I'll take area of triangle LMN to the numerator and area of triangle PQR to the denominator because it's given in that way. So now this will be what? Whether it is going to be 9 upon 16 or 16 upon 9. The rule is when you cross multiply, you should get this above step. So what will it be? Think well and write. So that's going to be 9 upon 16 because when you cross multiply, that is 9 multiplied by area of triangle PQR is equal to 16 multiplied by area of triangle LMN as it is given. So that's what we'll take it as 1. Now we'll write down triangle LMN similar to triangle PQR. It's given to us. So if triangles are similar, we can apply the theorem of areas of similar triangles. So let's put it. So since we are given mn square, we are given mn and qr. So I have taken it as mn square upon qr square because we are interested in mn and qr. That's why I have written it, and the reason will be theorem of areas of similar triangles. Now look at the step number 1 and 2. Area of triangle LMN upon area of triangle PQR. Both step number 1 and 2 have got the same things on the left hand side, which means our right hand side should also be same. So that's what I wrote. Mn square upon QR square is equal to 9 upon 16. Now have a look at the M from 1 and 2. Now have a look at this Mn square. It's a perfect square of Mn. Have a look at QR square. It's a perfect square of QR. 9 is a perfect square of 3. 16 is a perfect square of 4. So we can write taking square roots on both sides. It will become Mn upon QR is equal to 3 upon 4. Now QR value is given to be 20. So we can substitute that value of QR as 20 and then we will cross multiply. Mn is equal to 20 multiplied by 3 upon 4. Do the calculation, you will get Mn to be 15 units. So this is how we do sum number 4. Let's move on to 5. Areas of two similar triangles are 225 square centimeters and 81 square centimeters. That and is missing here. If a side of a smaller triangle is 12 centimeters, then find corresponding side of the bigger triangle. So here again, we will assume a triangle ABC similar to triangle PQR, and therefore we'll consider area of triangle ABC as 225 square centimeters and area of triangle PQR as 81 square centimeters. If a side of the smaller triangle is 12 centimeter, so which means smaller triangle they have specified. So which is our smaller triangle? Look at area of triangle ABC, it is 225. Area of triangle PQR is 81. So which do you think is a smaller triangle among this? Yes, it's triangle PQR. So we have to put the side of triangle PQR only to be 12 centimeter and not the side of triangle ABC. So side of triangle PQR is 12 centimeter, means I'll assume PQ to be 12 centimeter. Now the two triangles are similar, so we can apply the theorem of areas of similar triangles. So the reason here I'm writing it. Now we can substitute the values. Area of triangle ABC is 225, area of triangle PQR is 81 and PQ is 12. So let's substitute the values. Have a look at this step. 225 is a perfect square of 15. 81 is a perfect square of 9. AB square is a perfect square of AB. 12 square is a perfect square of 12. So we can take square roots on both sides. Now we will cross multiply. Do the calculation. You will get AB to be 20 centimeter. So the question asks, find the corresponding side. Therefore, corresponding side of the bigger triangle is 20 centimeters. Let's move on to number 6. Triangle ABC and triangle DEF are equilateral triangles. If area of triangle ABC is to area of triangle DEF is 1:2 and AB is 4, find DE. So we are given triangle ABC and triangle DEF are equilateral triangles. Now equilateral triangle means all the angles are of 60 degrees. So all the three angles of triangle ABC will be 60 degrees and all the three angles of triangle DEF is also equal to 60 degrees. It means angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, which means the two triangles are similar by AA test of similarity. Now, if the two triangles are similar, we can write the theorem of areas of similar triangles. Now, here we are given area of triangle ABC is to area of triangle DEF is 1:2. So, we can apply that here 1:2 and AB value is given to be 4. We can put that also. Now, look at this step. 1 is a perfect square of 1. 4 square is a perfect square of 4. D square is a perfect square of DE. But 2 is not a perfect square. So we will not be able to take the square roots. We have to cross multiply in this stage only. So let's do it. D square is equal to 16. That is 4 square is 16 into 2. Now, we have to find DE, which means we have to take the square roots of D square, which means taking square roots. Square root of DE square will be DE is equal to 16 multiplied by 2. Take the square root, that is 4 root 2 units. So the question asked is find D. So accordingly, this is our final step. Let's move on to number 7. In figure, segment PQ is parallel to segment DE. Area of triangle PQF is equal to 20 square units. PF is 2 dp. Then find area of quadrilateral DPQE by completing the following activity. Area of triangle PQF is given to be 20 square units actually. PF is equal to 2 dp. Let us assume dp is equal to x, therefore pf will be 2x. Let's fill it up. df is equal to dp plus pf. Now dp value is x, so let's fill it up. pf value is 2x. So we get x plus 2x is equal to 3x. In triangle FD, look at the triangle FDE and triangle FPQ. Angle FDE is congruent to, yes, angle FPQ, and the reason will be corresponding angles. Let's angle FED is congruent to angle FQP, and so let's fill it up. Therefore, triangle FDE is similar to triangle FPQ AA test. So therefore, area of triangle FDE upon area of triangle FPQ, yes, we can apply theorem of areas of similar triangles. So that will be FD square upon FP square. FD square upon FP square, and FD square, FD, we have got the value to be 3x, that is DF is 3x, and FP, we have got it to be 2x. And so 9x square upon 4x square. X square and x square will get cancelled, and that's how we get 9 upon 4. They have done it. So now area of triangle FDE is equal to 9 upon 4 multiplied by area of triangle FPQ. And what that is equal to 9 upon 4 multiplied by area of triangle FPQ means this is what is given, 20 units. So let's put it up here, 20. So now do the calculation. 4 in the denominator, 20 in the numerator. 4 5s are 20. So 9 5s are, it will become 45. So area of triangle FDE, we are getting to be 45 square units. Now area of quadrilateral DPQE is our question. So that will be area of triangle FDE minus area of triangle FPQ. So area of triangle FDE, we found it to be 45. So we will put that, and area of triangle FPQ, they have given it to be 20. Let's put it, and when you minus it, you will get it to be 25. And always the areas you need to be written as square units. So this is how we do sum number 7. With this, we complete our similarity chapter. Practice set 1.4 is over, and also the similarity chapter is over with this. You can attempt the problem set. So keep practicing. Go through all the proofs that you have learned in this chapter: basic proportionality theorem, angle bisector theorem, theorem of three parallel lines and their transversals, areas of similar triangles. All these theorems you need to know. So please go through the proofs and also keep practicing the sums, go through the solved sums, and that's all for today. Thank you.